Hey guys, this video is about negative exponents. I'm sure you guys are very excited about negative exponents. A lot of us kind of don't like negative numbers, especially when they're exponents. So this video is to sort of get rid of all those fears about negative exponents and have you guys just see it's actually not as bad as you think. So to give you just a shortcut of negative exponents, if you have an example question that looks like this, 2 to the power of negative 3, you notice that there's a negative exponent, right? What you do with this 2 to negative 3 to make it a positive exponent is actually quite simple. You notice that every number, this is a very important point right here, is that any number, doesn't matter what it is, by itself can always be written in a fraction. And in this case, we can always write this in a fraction by just doing a fraction line. And what's going to be the denominator? 1, because any number actually has a denominator of 1. So in order to make this exponent positive, we are actually going to flip this and put this in the bottom, in the denominator. So I'm going to write my fraction line. This is my fraction line, a really thick one. And to make this positive, I'm just going to make that positive. And my base stays the same. And I can't just have a number in the denominator, so I need to put a 1 over it. So that's it. That's all you have to do. In order to make this negative into a positive exponent, just flip it into the other side of the fraction. So if you start off with something like this one, on the other hand, where your negative exponent is in the denominator, in this case, how do we make that positive? Well, we see there's a fraction. In order to make this positive, bam, put this at the top. So base stays the same, 2. And that exponent changes from a negative to a positive. And we finish off with the 1. Simple as that. Let's try another example. Let's go with brackets, negative 4, and then outside the brackets we have a negative 2. So when you see the brackets and a negative sign, it's like, oh, I don't know what to do. But it's actually quite simple because this bracket is like your box. So it doesn't matter what it is. This is still the base for this exponent. So whatever base you have stays the same. And this can be written in a fraction sense so that we drop this 1 just to make it look like a fraction because then it's easier to see. And then to make this a negative exponent to a positive, put it in the bottom. Bam. So this becomes positive 2. And then what's your base? Well, this bracket, a parentheses or brackets, whatever you call it, it's boxed out. So you're just going to keep it the same, negative 4. Are you done? No, because you just create a fraction. You flip this fraction. So this 1 has to go at the top. That's it. Okay? So this is how you get a negative exponent into a positive one. Well, what if you started an exponent at the bottom? So negative 3, negative 2. Well, this is already a fraction. Bam, put it at the top. Base stays the same. Negative 3 is your base. How do you make this negative to positive? Put it at the top. Are you done? Yeah, you're done. Can you do this over 1? Sure, same thing, because whatever divide by 1 is what you started off with. So that's your negative exponents. So here's a couple tricky ones. What if you had 2 to the power of negative 3 and then 3 to the power of negative 2? How do we make those exponents positive? Well, simple, because this is still a fraction. Anytime you look at this, this is negative. To make this positive, well, go to the bottom, to the denominator. So positive 3. What's your base? Your 2. Put it there. And then what's your exponent for the other one? Negative 2. So in order to make this positive, bam, flip it to the top. Positive 2. What's your base? 3. That's it. If you want to break it down and see what actually happened, we can see that 2 to the power of negative 3, 3 to the power of negative 2, this is just like 2 to the power of negative 1, 2 to the power of negative 1, 2 to the power of negative 1, 3 to the power of negative 1, 3 to the power of negative 1. Okay? And if you want to flip these ones, you can see that they all become positive. 3 to the power of 2 and 2 to the power of 3. That's if you were to flip the reaction. If you really wonder how this works, it's actually, here's a proof to this. If you are interested in it, here you can check this out. 3 to the power of 2 divided by 3 to the power of 2. Let's look at this question. we're going to prove how that sort of flipping works. This is a same base and division. Anytime we are dividing, we're going to subtract these. So it's going to be 3 subtract 2. Oh, I don't know where I get that 3 from. 2 subtract 2. This becomes 3 to the power of 0, which is 1. So how does that work? Let's look at this again. 3 to the power of 2 divided by 3 to the power of 2. Well, since you're subtracting, that's your subtraction sign. And since this is going to equal to 1, right, because we just proved that that's equal to 1, what if we were to divide both sides? This is kind of getting into systems of equation. What if we were to divide both sides by negative 2? 3 to the power of negative 2. This one will cancel out. So then you're going to left with 3 to the power of 2 is equal to 1 over 3 to the negative 2. This is just to prove how this works. Okay, so remember, don't forget the flipping and don't forget the one that's either on top or the bottom, because that will pay a big difference. So here's the video on negative exponents, and shout out to Brayden because he's a loyal viewer. He's been liking this video, and thank you for watching. I'll see you next time.